Hi students, welcome to IGCSE at Fingertips. Today we are going to solve a physics paper which is MCQ of year 2021 variant Feb March and number 22. The paper is of MCQ, you just have to answer A, B, C or D. You do not need to show your methods. You will be provided answer sheets in which only options have to be written. So let's start with the first question. A student has a measuring cylinder containing water and also has a balance. Which of these could she use to find volume of a small metal sphere? If I wanted to find volume of a small metal sphere, I would need only measuring cylinder and water, right? I wouldn't require balance. If I was measuring density, I would require balance. So let's find out if we have our correct option. A, either measuring cylinder containing water or the balance. The measuring cylinder containing water only. So A is correct. We don't require the balance or the balance is written. It's partially correct, but we have our answer as B. Option B is the correct answer. Let's look at question number 2. A ball hits a bat with a velocity of 30 meters per second. Okay, and leaves the bat traveling with a velocity of 20 meters per second in opposite direction, right? So the ball is going in the opposite direction. The ball is in contact with bat for 0.10 seconds, correct? So it came with 30 and it went with 20, right? But it went with 20 in the opposite direction, which means we have to take minus 20. So the difference between 30 and minus 20, or we can simply write A is equal to V minus U by T. Our final velocity minus 20, initial velocity 30 upon time for which is in contact with bat 0.10. This will give you minus 500 meters per second square. But because none of the given answers are in negative sign, we'll just write the option D is the correct option, because only this option matches the magnitude. Question 3. A train begins a journey from a station and travels 60 km in a time of 20 minutes. What is the average speed of the train? We know the formula for average speed is total displacement upon total time. So let's just write that down and find out what our answer will be. Make sure that you look at options, because the options are only in meters per second. So your answer calculation must be in meters per second. So I'll change 60 kilometers into meters by multiplying by 1000, and I will change 20 minutes into seconds by multiplying that 2 with 60. 60 gets cancelled and you have 50. 50 meters per second. So your option C is the correct option. Okay guys, I am solving it without a calculator, but you are allowed calculator. You can use calculator if you find these calculation difficult. Question 4. Which statement about mass is correct? Mass of 10 kilogram weighs 1 Newton near the Earth's surface. No. Mass of 1 kilogram weighs 10 Newton near the Earth's surface. That will be the correct statement. B. Mass is a gravitational force. No. Mass is the amount of matter contained in a body. C. Mass increases when gravitational field strength increases. No. Mass is a constant quantity. D. The greater the mass of a body, the more resistance the more it resists a change in its motion. Correct. The more the mass, the more the inertia. So our option D is correct. Let's look at option number 5. A small bottle has a mass of 20 gram when it's empty. The volume of the bottle is 10 centimeter cube. When full of liquid, the total mass is 150 gram. I'm sorry. What is the density of the liquid? We know the formula for density is mass upon volume. What is the mass of the liquid? The mass of liquid is difference in these two masses. So it will be 150 minus 20 divided by the volume of the bottle, which is 10. So you'll have 130 upon 10, which gives you 13 gram per centimeter cube, which is our option C. Okay, let's look at the next question. An object of mass 0.80 kilogram is moving in a straight line at a velocity of 2 meters per second. A force is exerted on the object in the direction of motion for a period of 1 minute, and the velocity of the object increases to 6. So it goes from 2 to 6. The velocity goes from 2 to 6. What is the force exerted on the object? It's a very pretty simple straightforward question. We already know that force is nothing but rate of change of momentum. So I can write it is nothing but m into v minus u upon t. Correct? The mass is given 0.80 gram and you have initial velocity 2, final velocity 6. So I'll write 6.0 minus 2.0 and it stays in contact for 1 minute. But the standard unit for time is seconds, so please don't forget to change it to seconds. Correct? When you find this out, let me also take calculator in this question. So it's 0.80 multiplied by 4 divided by 60, which gives an answer 0.053333 repeated Newton. So I will mark option A as the correct option. Okay, let's look at question 7. An object moves at constant speed in the direction in the circular path shown. Which statement about acceleration of the object when it is at point P is correct? The acceleration is in the direction of arrow X outward. The acceleration is in the direction of arrow Y downwards. Acceleration is in the direction of arrow Z towards the center, and the object is not accelerating. Now see, the object is moving. It is performing a circular motion, and to perform a circular motion it must have a force which pulls it inside, otherwise it would go straight, which means you have to write, and your correct option is C. The acceleration is in the direction of arrow Z towards the center of the circle. Okay, let's look at the next question. An object is pivoted at point P. Okay, it's pivoted at point P. A student ties a length of string to a peg on the object. He pulls the string with a force F. So he's pulling with a force F shown here. This is the peg. So he ties something here and then pulls it. What is the moment of the force F about the pivot? What is the formula for moment? Moment is force multiplied by perpendicular distance, and your perpendicular distance is this S. So the moment of force about the point P is going to be Fs, and your option is C. The correct option is C. Okay. Let's see what the next question gives us. 9. A gas molecule strikes the wall of the container. Molecule rebounds with the same speed. See, that's a keyword here. It rebounds with the same speed. What happens to kinetic energy and what happens to momentum? So what happens to kinetic energy and momentum? Because it is same speed, I can definitely write that the kinetic energy stays constant. So either option C or option D can be my option. Then does the momentum change or stay same? Now remember here, the formula of momentum is P is equal to mv. Velocity is a vector, momentum is also a vector. When the gas molecule is coming towards the wall, it has a momentum P, but when it is going back, it has a momentum minus P. Why? Because its velocity is the same, but the direction has changed. So I'll write the momentum also has changed, and therefore my correct option is option C. The correct option is option C. Question number 10. A horizontal force pulls a box along a horizontal surface. The box gains 30 joules of kinetic energy and 10 joules of thermal energy, which is produced by friction between box and the surface. How much work is done by the force? Now, due to the law of conservation of energy, that energy can neither be created nor be destroyed, we can write that this total change is brought by the work done. The total change is 40 joules, and there must be an option which has 40 joules as answer. It's option D. A crane is used to lift loads vertically. The output power of a crane to lift a car is P. So this is our power. The crane then lifts a lorry. Now if it was lifting a car, the power was P. Now it's lifting a lorry, which has 3 times the weight of the car and moves through 0.25, only 0.25 of the distance in 0.5 times of the time, only half of the time. Now remembering the formula of power, power is work done upon time, and work done is force into displacement upon time. Also remember, all the kinds of weight are forces. All the kinds of weight are forces. So when they say 3 times the weight, it's nothing but I'll write here power is equal to force. But the new force is 3 times of F. Let me write P2. Correct? Because here we already have power is equal to Fs into T. So P2 is equal to 3 times of F, 0.25 times the distance. So I'll write 0.25 S divided by 0.50 times the time. So 0.50 into time T. Can we write this as 3 into 0.25 into upon 0.50? This is the numbers, and we can definitely multiply all the constants like this. This simplified will give you 1 times, 2 times and 1.5 times. Okay, so it is given 1.5 times the initial force, 1.5 times, I'm sorry, the initial power. Now let us adjust this a little bit so I can show you the options clearly. Can you now identify your answer? The answer is 1.5. Do any of these simplify to 1.5 times the P? The correct option will be B. 3 by 2 is 1.5 times, and that's your answer. Okay, next question. Diagram shows a manometer connected to a gas supply. So this is from the gas supply. This is mercury. What is the pressure of the gas supply? Now, even before looking at options, you can find it out easily. Look here. What is the difference between pressure? It's 300 here and it is 100 here. So this height is nothing but 200. 200 what? 200 millimeter of Hg. Okay, so the pressure of the gas is 200 millimeter of Hg, more than the atmosphere, because the other side is always connected to or exposed to atmosphere. Now let's read the question. What is the pressure of the gas? It is 200 mm of Hg above the atmospheric pressure. Even without going through all the options, we know our answer. Okay, question number 13. Diagram shows a box of dimensions 6 into 8 into 4. Box rests on a floor horizontal to the surface. On which face must the box rest in order to exert least pressure? Now see, on whichever face the box rests, its weight is going to stay the same, which means the force exerted is going to stay the same. What is going to change? The area. If you remember the formula of pressure, pressure is equal to force upon area, and therefore pressure is inversely proportional to force. The larger the area, the lesser the pressure. Pressure is inversely proportional to area, and the larger the area, the lesser the pressure. On which face must the box rest in order to exert least pressure. So the area must be largest. Let's find out which of these area is largest. 6 into 8 is 48. Okay, 6 into 4 is 24 and 4 into 8 is 32. Which is the largest area? 48. Now which of these three is the area that has these three corners? So let me just erase this quickly and let's identify that area. Let's identify that face. So this is given as 8, correct? So the face X is your correct option. Face X is your correct option. Okay. Question number 14. Air in a sealed syringe is slowly compressed by moving the piston inwards, obviously. Temperature of the air stays the same. Which statement about the air is correct? So if temperature stays the same and volume is changing, we know we can apply P1 V1 equals to P2 V2. Let's find out if there is something like that here. Option A, the pressure of the air decreases because its molecule now travel more slowly. No, the travel of molecule is neither faster nor slower because temperature of the air stays the same. So let us identify obvious incorrect answers. The pressure of the air decreases because the area of the syringe wall is now smaller. The area of the syringe wall is smaller. But does the pressure of air decrease? If it is compressed, the pressure must increase. If they say it is decreasing, it's obviously a incorrect option. Pressure of the air increases because its molecule now hit the syringe wall more frequently. Okay, maybe. And the pressure of the air increases because its molecule now travel more quickly. They cannot travel more quickly. Why? Because the temperature is same. So your only correct option and the obvious answer is option C. Okay. Next, in an experiment, smoke particles are suspended in air and viewed through a microscope. Smoke particles move about with short random movements. Which of the following statement is correct? Air particles have large masses compared to smoke particles and they move in one direction only. Okay. Air particles have large masses compared to smoke particles and they move in random directions. Okay. Air particles move at high speeds compared to smoke particles and they move in one direction only. And air particles move at high speeds compared to smoke particles and they move in random directions. So all these options seem to be a little bit confusing. So let's quickly now find out which are the obvious incorrect answers. Now, the first obvious incorrect answer is your option C. Why? It says that they move in one direction only. The answer, or rather the question, is about random movement of particles, and random movement is nothing but random directions for random amount of time. Now they are talking about mass and speed. Okay, air particles have a large mass compared to smoke particles. Okay, that is the common theme between option A and B. So if you find out they are correct, your answer is only of A and B, and if you find that it's incorrect, your answer, both the options are incorrect and your obvious answer becomes D. So let's read them again once more. Air particles have larger masses compared to smoke particles and they move in one direction only. Oh, there is one more obvious incorrect answer. This is incorrect. Air particles have large masses compared to smoke particles and they move in random directions. Now we cannot say air particles are more heavier or lighter because air is a mixture of gases. You cannot say this with certainty. So this option cannot be taken as correct option and you're left with D. Now air particles move at high speed, which is the correct answer. The air particles move at high speed compared to smoke particles and they move in random directions as well. So that will be our answer. Let's look at next question. Graph shows how the internal energy of 1 kilogram of metal changes with temperature. Okay, so let us identify certain points in this graph. Internal energy goes from 800 and it goes to 830. Okay, it happens over a temperature of, the delta T is 100 degrees Celsius or 100 Kelvin. The difference stays the same for both Kelvin and Celsius scale, and they are saying that there is 1 kg of metal in this. So what is internal energy here? Internal energy is nothing but heat energy, or the heat contained inside this body. Okay, what are they asking? What is the increase in internal energy of the block of same metal, okay, of mass 0.25 kilogram, when its temperature rises from 40 to 50 degree Celsius? So what are they asking? They are asking what is the change in heat energy if the temperature is already given. In other words, they are asking what is the heat energy stored by this body or gained by this body when it goes from 40 to 50 degrees Celsius. There is only one way to find this, and that is by finding the specific heat of this body. So let's first find specific heat. We have 30 kilojoules of change in energy for a body of mass 1 kg. Our formula is H is equal to mc delta theta. So it's m is 1, mass is 1 kilogram, c is unknown, but delta theta is 100 degree Celsius. Correct? So I'll take 30 into 10 to the power 3 divided by 100. This will give me 300 kilojoules per kg degree Celsius. So 300 kilojoules per kg degree Celsius is your specific heat energy stored by this body. Now let's look at what do they want us to find. They want us to actually find that if this body is taken, its temperature changes by 10 degrees Celsius and its mass is only 0.25 kilogram, what is the change in its internal energy? To do that, let us simply take H is equal to mc delta theta, which is nothing but 0.25 multiplied by 300 multiplied by 10. Okay, let's find out 0.25 multiplied by 300 multiplied by 10. That is nothing but 750 joules of energy, and that is your answer C. This is nothing but 750 joules of energy. Now let us look at next question. A piece of melting ice at 0 degrees Celsius and a beaker of boiling water are both in laboratory. The laboratory is at 20 degrees Celsius. Okay, so these are the keywords. Okay, it's melting ice at 0 degree and boiling water. Boiling water is at 100 degrees Celsius, but the temperature of the lab is only 20 degrees Celsius. The question is asking what is happening to the temperature of melting ice and what is happening to the temperature of boiling water. Now melting ice and boiling water both are state changes. When state is changing, none of the object change their temperature. So both of them will be constant, and your correct option is option A. Both of them will be constant and your correct option is option A. Okay, question 18. One end of copper rod is heated. What is one method by which thermal energy is transferred in the copper rod? Okay, free electrons transfer energy from cooler end to the hotter end. Why would they go from cooler end to the hotter end? No, incorrect answer. B. Free electrons transfer energy from hotter end to cooler end, which makes sense. They will try to move towards the place where heat energy is less. They will move from higher level to lower level, and your option B is the correct option. Which change will cause decrease in the rate of radiation emitted by an object? Okay, so the rate of radiation depends how dark an object is, what is the surface area, and what is the temperature. They are directly proportional. Darker the object, more the radiation, more the temperature, more the radiation, and more the surface area, more the radiation. Okay, Let's see. Number Option A, changing the surface color from white to black. No, radiation will increase. B, changing the surface texture from dull to shiny. Okay, makes sense. Increasing the surface temperature or increasing the surface area. And option B is the only correct option. Let's look at question number 20. What is the approximate wavelength in air of the highest frequency sound that can be heard by a normal healthy person? Now make no mistake guys, they are not asking what is the frequency. The obvious answer 20,000 you would go to. No, they are not asking frequency. What they are asking? They are asking us what is the highest wavelength in the air of the highest frequency sound. What is the highest wavelength of the highest frequency sound? We know that velocity is equal to F into lambda. Now, what is the approximate speed of sound in air? Let's take it 300. Okay, let's take it 300. It can be taken as 340, sometimes it can be taken as 330. I'm taking it as a standard 300 for this answer. What is the highest frequency sound that can be heard by a normal healthy person? It's 20,000 hertz. So 20 kilohertz, right? And this will be nothing but lambda. Let's quickly take our calculator, find our answer. 300 divided by 20,000. It gives answer 0.015. Okay. If I had taken velocity near 340, 350, I would get nearly answer 0.02. And if we round off 0.015 to the nearest second decimal, I do get 0.02. So that's our answer. What causes change in direction when light travels from air into glass? Okay, the amplitude of the light changes. Okay, color of the light changes. How can color of the light change? Color depends on frequency. Frequency of any signal depends only on source. So this is definitely not our correct answer. Frequency of the light changes, as I just said, this is also not our answer. And the speed of the light changes. See, amplitude of the light will never change. Okay, when it is undergoing refraction, even amplitude will not change, only the speed and wavelength change. So here we have only speed, and therefore this is our correct answer. Light from a torch is incident on a plane mirror. The angle of incidence is 38. What is the angle of reflection? The first law of reflection. The angle of incidence and the angle of reflection are equal, and your correct answer is 38 degrees. Okay, let's look at question 23. Two rays with an angle of incidence 60 degree pass into dilute and concentrated sugar water solution. The refractions are shown. So here this ray of light has change of the angle. The angle becomes 40, and for this it becomes 35. This is concentrated and this is dilute. Which row is correct? Refractive index, as concentration increases, the more the refractive index, the higher the angle of the more this angle, the more this ray shifts towards the normal ray, right? This is the normal ray. The higher the refractive index, the more the shift there is. Okay, out of these two we can observe the concentrated sugar solution has a more shift. So refractive index, as the concentration increases, refractive index is increasing. So your option C or D, these are the only two options that can be correct. Speed through the solution, as concentration increases, the more the refractive index, the lesser the speed gets. So the more the change, okay, less refractive index, higher speed, more refractive index, lower speed in that medium. Speed through solution, as concentration increases, more the concentration, lower the speed. So your option C is the only correct option. Option C is the only correct option. Let's look at question 24. A thin converging lens is used to produce a sharp image of a candle. Okay. Various sharp images are produced on the screen. They are all produced on the screen by moving the lens and the screen backwards. What are they doing? They are making large, just one second, they are making large images and sharp images on the screen by moving the lens and the screen backwards and forwards. Which statement is always correct? They've already given us a hint. They are forming the image on the screen. Image is at the principal focus. No, they are moving it, so it may not be at the principal focus always. The image is bigger than the object, maybe. The image is closer to the lens than the object, maybe. The image is inverted. Which one of them is always correct? If it appears on the screen, it's a real image, and real images are always inverted. So your only option is option D, always correct. Otherwise, other options may also be correct. Okay. What is question number 25? Which row gives the approximate speed at which ultraviolet light wave travel in air and in a vacuum? Okay, so ultraviolet waves are nothing but light waves. They always travel at the same frequency or same velocity in air as well as vacuum, approximately same, right? There is no drastic change in their velocity. So your option is option D. Okay, answer number 20. Question number 26. Diagram represents a sound wave. Okay, what are the names of the parts of the sound wave? Label X and Y. Here a lot of waves are together, so it is compression. Here the waves are sparse enough, they are far away from each other, so it's a rarefaction, and your answer is option B. Question 27. The speed of sound is different in different states of matter. Speed of sound in liquid water is 1500. Which row correctly compares the speed of sound in ice and the speed of sound in water vapor with the speed of sound in water? So the more density of the object, the higher the speed of sound in that object. So ice is denser than water and water vapor is less dense than water. So I can easily say that in ice the speed of sound will be more than 1500 and in water vapor it will be less than 1500. Let's see if we have that kind of option. Speed of sound in ice more and speed of sound in steam less. It matches at option C, and this is our correct answer. Let's look at question number 28. Three methods to demagnetize a magnet are suggested. The magnet is in a east-west direction. Number 1, hitting the magnet repeatedly with a hammer. Okay. Heating the magnet until red hot. Withdrawing the magnet from a coil which has a direct current in it. Which methods demagnetize the magnet? Constant hammering does demagnetize. Then heating the magnet until red hot does demagnetize it. But withdrawing the magnet from a coil which has direct current in it, it's already a magnet. Even if you withdraw it, it may not get demagnetized. So your option 3 is incorrect. A has option 3, C has option 3 and D also has option 3. You're only left with option B, which is the correct option. Then let's look at the next question. 29. Three cores of different metals P, Q and R are placed inside identical coils of wire. So the coils of wire are same, but the cores are different, P, Q and R. At least one of the metals is non-magnetic. The cores are held above some iron nails. So whichever does get magnetized will attract these iron nails. Okay. The diagram shows what happens when there is current in the coil. Q and R attract the nails. The three diagram below show what happens when current is switched off. Q demagnetizes, P was not magnetic even in other condition, and R stays magnetized. Which core metals are magnetic? If by passing current, if by passing current the core becomes magnetic, it is magnetic. There is no question in if P is magnetic or not, it is not. But here Q may confuse you, because when you pass current it does get magnetized. It is magnetic by nature, it will be influenced by magnet. So your answer is Q and R, which is option D. Okay. Question number 30. Two uncharged metal spheres X and Y rest on insulating stands and touch each other. A negatively charged plastic rod is brought near the sphere X. Okay. Using insulating stand, sphere Y is moved away. So no charge leaks through when you are moving it. Okay. What are the signs and the relative magnitudes of charges induced on X and Y? Let's first understand what happens. When you bring this negative charge very near, all the electrons that are in this X sphere will try to move away, because like charges repel each other. These are metal spheres. Electrons can move freely. These all electrons would try and move to metal sphere Y. In this case, what will happen? In this case, that there is a deficiency of electrons in one metal sphere and there are too many electrons in the other. So this is positively charged because it has less electrons, and this is negatively charged, but both the charges are equal. Why? How many ever electrons transfer here, Y becomes equally negatively charged and X becomes equally positively charged. So what is the charge on X? The charge on X is positive, the charge on Y is negative, and the relative magnitude of charges are equal. So you have option, no, I'm sorry, you have option C. The correct answer is option C. Then let's look at question 31. Which two charges, which two changes to a metal wire both decrease its resistance? So let us just, for our understanding, write the formula of resistance. Resistance is rho L by A. Okay, rho is resistivity, L is length, and A is the cross sectional area. So let's see, length of wire. If you increase the length of wire, resistance is going to increase. So let's check which of them can be correct. Decreasing the length of wire can work in decreasing the resistance. You want to decrease its resistance. And increasing the cross sectional area. So decrease, and this increase. So your correct option is option B. Let's look at question 32. There is a current I in resistor of resistance R for a time T. The potential difference across its resistor is T. Okay. Which equation gives energy transfer by the resistor? We know that energy transfer, the power is given by V into I, and energy is nothing but power into time. So energy is V into I into T, and that is your option D, IVT. Okay. Let's look at the next question. Question 33. A resistor R is connected in parallel with 8 ohm resistor. The resistance of this combination is 4 ohms. Okay. What is the resistance of resistor R? Can I write 1 by 8 plus 1 by R is 1 by 4, right? Because the resistance of this combination is 4 ohms. From this I can write 1 by 8 minus 1 by 4 is 1 by R. Just a second, this is a little bit incorrect. Okay, so we have 1 by R is equal to 1 by 4 minus 1 by 8. This is 8 minus 4 by 32, which is 4 by 32. So 1 by 8. What is the resistance? The resistance is 8 ohms, right? This is your resistance, not 1 by 8. Your resistance is 8 ohms, and your option is option D. Okay. 34. A student designs a circuit to use as a dimmer switch for a lamp. What happens to the brightness of the lamp and the potential difference across the lamp when the slider is moved from X to Y? So when the slider is moved from X to Y, the resistance due to this slider will increase. When it increases, the lamp will become less and less bright. And it will become less and less bright because the potential difference across the lamp decreases, right? So your option is option A. Your option is option A. Question 35. The circuit shown contains two gates. Okay. Which truth table describes operation of the circuit? First, let's identify the gates. This gate Q is a NOT gate and the gate here is an OR gate. NOT gate changes the input. If the input is 0, the output becomes 1. If the input is 1, the output becomes 0. Okay. And OR gate is when either of one is true. One is true. Either of them is true. Your answer is true. Your answer becomes true. Right. So with that regard, let us understand. Okay. So P is 0 and Q is 0. So I'll just make a correct truth table so that we can understand. If the input of Q is 0, the output here will be 1 for that. Correct? So let us make a truth table. I'll write P Q dash, right? Let's make it somewhere else. Okay. So it's P Q dash and our output. Okay. So P is 0 0 1 1. Q, if it is 0, the actual input will be 1. Again, when Q is 1, the actual input will be 0. When the Q is 0, the actual input will be 1 and again 0. OR gate, either of them is true, the answer is true. So your truth table becomes 1 0 1 1. Which of them has this resemblance? Okay, option D. Your correct option is option D. Next question, 36. Diagram shows an electromagnet near a coil of wire connected to a voltmeter. The reading on the voltmeter is 0. Switch is then closed. Electromagnet magnetizes quickly. What happens to the reading on voltmeter? It keeps increasing. No, the voltage is not changing. The voltmeter reading will not keep increasing. It quickly increases and stays maximum. No, quickly increases and then decreases. Yes, because an electric field is induced and therefore it quickly increases, but because the changing electric field becomes constant and the electromagnet's magnitude becomes constant, the voltage again decreases. So your option is C. The correct option is option C. Which graph shows the voltage output of AC generator with peaks and zeros correctly? Okay, so it's a generator. It has not passed through a rectifier. So these cannot be zeros. These also cannot be zeros. Okay, these can be zeros and these are correct peaks. Okay, these are not the correct zeros. So your only correct option is D. Your only correct option is option D. Let's look at question number 38. Three students are describing the structure of an atom. Student 1 says all positively charged particles are in the nucleus. Okay. Positive electrons are in the nucleus. Okay. So student 2 is definitely incorrect. Electrons are not the positive charged particle. Protons are the positively charged particles and they are in the nucleus. Student 3 says negative electrons orbit around the nucleus, which is a correct statement. So student 2 is wrong. Option A is wrong, option B is wrong and option D is wrong. You are left with only option C, which is your correct answer. Let's look at question 39. When alpha particles are incident on a thin metal foil, most of them pass through undeviated. What does this observation reveal about the nature of atom? It reveals that atom is mostly empty space. Okay, atom is mostly, the statement is directly given. Let's take it right away. Let's look at the last question of our paper. This will be the last question. A laboratory worker measures the count rate from a radioactive source. He records his result in a table. Okay, this is the table. The average background radiation in laboratory is 8 counts per second. What is the half life of the source? Before we count the half life, we must deduct this background radiation. So here we have 92 counts, the actual count. Here we have 65 counts. Then here we have 46 counts. Again minus, so we have 33 counts and we have 23 counts. So when does the count rate become exactly half? We start with 92. 92 divided by 2 is 46. When does count rate become 46? It becomes 46 at 2 minutes. So what is the half-life of our sample? The half-life of our sample is 2 minutes. The correct option is option B. That's your paper. Please leave your feedback and comments in the comment section below. If you want more papers to be solved, please mention that as well. Thank you for watching. Bye bye.